All right, make me feel it. Class?
Yes.
Thank you. At least pretend to be happy to be here. Thank you very much. Okay, so we're on 43, and we're still doing the Eulers here. But now this is actually a real life type of situation. As long as you're not on your phone and you missed the last 9 weeks, you might want to pay attention to this. So on this one here, we're taking a look at this. And it says, street map below represents a town with streets, residential blocks, and a town park. 2 blocks indicate the arrows contain meters that a parking control operator travels on foot to check. So this is the one we're talking about. So we got these 2 buildings, and there's a street going down the middle, right? So that means that there's also parking meters inside there on both sides of the street. Okay? All right, there's sidewalks on there. Now, let's see, graph below represents the 2-block area. Here are my goals. Parking control office must cover all the sidewalks that have parking meters without retracing any steps more than are necessary. Suppose the officer must start and end at vertex A. Here's A. Use your pencil to draw a circuit the officer could follow. Label your diagram with numbered arrows to indicate the order of your edges. So what you're going to do right now, we're going to follow all these paths. And if you notice right here, B has 2 going off of it because at B, from B to E, there's 2 sidewalks there. There's sidewalk on the left side and there's sidewalk on the right side. So you, write me out. I would like for you, please try it out. Please try it out on your paper. Please try it. This should be an easy puzzle for anyone. Should be. And number your path. Number your path. We're starting on A and number the path. So number the path that you go. Where's the first place you went? Number that one. Okay, and then go from there. I think there's 8. Is there 8 there?
No, there's 7 unless you include the one you started with again.
Just the edges.
Yeah, wait. Yeah.
One, 2, 3, 4, 5, 6, 7, 8. Good job. All right, can you explain where we go?
I did go.
All right, we got it yet? You got 1 so far. Keep numbering. All right, who wants to come up and do this one? Who's got this? There.
I don't know. Let's see.
Come on.
Wait, really?
Yes, come try it. Because I think you can.
Give me the I thought I had to do the stand. Okay, I don't even know.
Okay, but as we go, you're gonna number. So trace it over. That's hold on. Number your segments. There's 1, 2, good. 3, keep going. Now, follow the path.
Right.
And that one's gonna be
5.
and 5 is going up. 5 is going up here. 5 would be this side, and then going back down would be
6.
right here 6. This side going back down 6, and that one is 7. And from D to A, 8. There we go. Good job. All right.
Candy.
Huh? I'm all out of candy.
A sticker.
Huh? Your candy. I might have one. I just have to find them. All right. Yes, it is. All right. So good job. So right here, there could have more than one answer though. You could have more than one. You could have gone a different way and still get the same answer. So is this one here a Euler circuit?
Yes.
Yes, because I used all the sides only once and I start and end at the same spot. Yeah. So that one is a Euler circuit. Now, look closely. Look closely at this because this is going to help out the next piece.
Okay.
How many edges does A have?
2.
2. How many edges does B have?
2.
3.
1, 2, 3, 4, right? It's got 4 going to it, doesn't it? Okay, how many does C have?
2.
How many does F have?
2.
How many does E have?
4.
And how many does D have?
Oh, 4. 2.
2, right? And then this was back to 2, right? So this one is a Euler's, right? This one is a Euler's, so let's go back to one that was not a Euler's. We know this one was not a Euler's here. How many edges does New York have? 2. There's 2 there, right?
Yeah.
How many edges does London have?
3.
1, 2, 3, 4. Okay, there's 4 lines going into it. How many edges does Berlin have? 3. How many does Rome have?
3.
How many does Miami have? Now, what's different from this one that from my other one?
Doesn't follow pattern.
What?
Doesn't follow pattern.
It's not really a pattern thing.
Doesn't match.
Not really. Huh?
Each dot has more connecting edges than the other one.
Okay, just think of the numbers that you had. Think of the numbers that you had and think of the numbers that are on this. So what do we have here? We had 2.
They're not even?
16. So there's
Look at you! Earn that sticker. And 4. There we go. So this one went 2, 4, 3, 3, 3. Wait, no, 3, 3. No,
2, 3.
I know, I put 3 too many times. 2, 4, 3, 3, and 4, right? There we go. So this one has some odd ones, where my other, everything is even, isn't it? Everything is even. So this has 2, 2, 4, 2, 2, and 4. So if they have even numbers of edges, can it be Euler's? Yes, it can. So if it's an odd number of edges, can it be Euler's? No. Okay, that's super important. So let's go back up to here. Said Euler circuits get their name from the great 18th century mathematician Leonhard Euler, who first studied them. Euler is considered the founder of theories of graphs or graph theory. One of Euler's first discoveries was that some graphs have no Euler circuit at all, like this graph. So this one is not a Euler circuit. So we go here, back around. Why is this one here not Euler circuit? It does not start and end at the same point. Very good. So that one's not a Euler circuit, but it is, okay, it is a closed circuit here. Okay, this one's closed, but it's not going to be a regular circuit. Okay, so it's not a Euler's. Because we're interested in finding circuits, and Euler circuits are the most efficient ones, we will want to know how to find them. If a graph has no Euler circuits, we will want to develop the next best circuits. Those having minimum deadheadings means, you know, ending in the wrong spot. Dead ends. So it has to be ending in the correct spot. 2 ways to find Euler circuit. Trial and error, that's what we did yesterday. Okay, keep trying to find a path that starts and ends in the same place and does not retrace steps. But the mathematical approach, a Euler circuit exists if the following statements are true. Now, I'm going to pull up my definitions here so you can see my statement. There you go. So your notes have this as fill in the blank. So we're right here, mathematical approach. You're going to fill in the blanks for these because your notes are fill in the blank. So I want you all to fill in the blank. No way?
Thank you.
Thank you for solving the problem. Not what Mom said.
We got burned.
Alright, so let's continue and fill these in now. It says all points vertices have an even. Okay, and valence, it refers to all the points going to it. So when you see the word valence, that means the edges, all the edges together. The graph is connected. Valence, the number of edges. What is it?
Meeting.
Meeting. At a vertex. Connected graph. Every pair of vertices has at least one path connecting them. All right? There we go. Now, let's take a look at our homework. And if you notice, this is the same homework from yesterday. Now, do you guys want new homework for 4.2? Okay, good. No homework for 4.2. We're just going to use this time to actually go back over 4.1. And for those people following along, I'm going to show you something on my Teams. It's 6th hour, right? Okay. So in Teams, what I have done, so you know that Friday is an I day, right? Yeah, that's the day that you don't come to school. Your assignment that I have for that day is right here, which is just the monthly survey. Remember, do you guys remember doing this? This is where you evaluate how well I'm teaching. And there is a comment section too, if you want to add something extra, like talking crap, but you know, that's no one in here. People in other classes. As I'm looking, she's not even paying attention. Anyway, so this is your I-Day assignment. It is due Friday. Please make sure you do it so I can count you present and accounted for here. And since Thursday is Dia de Pacho, yes it is. It is a Pacho day. I am feeling magnanimous. I will let you have the day off. Because it is my holiday, you could have the day off. You're welcome. Okay, anyway. So what this says is, it says, list the diagrams can be drawn without lifting your pencil from the paper and without drawing any sides more than once. So this means, does this one have to start and end at the same spot? Say no.
No.
It doesn't have to start and end at the same spot, but the part B, listed diagrams can be drawn without lifting your pencil, but with the additional requirement that you start and end at the same point. Now, what you're going to do is you're going to go through and you're going to start figuring this out. So start and end at the same point uses what vocabulary word? Euler's, thank you. So a Euler circuit starts and ends at the same point, right? Uses all the sides exactly once. And did we just figure out a way to figure out if it's a Euler's or not? Now, let's see down here. There you go. All right, so let's take a look right here. I'm going to jump to number 5. And this is how you do this. So in number 5, if I could do this, I'm going to trace it out, and it says number your paths as we go. So this is going to be 1, right? 2, 1, 2, 3, 4, 5, 6, 7, 8. So, did I start and end at the same place? Yes, I did. I started and ended at the same place here. So, what type of circuit is this? Euler's, right? That's going to be Euler's. And I can also look and see how many edges does this one have?
2.
How many does this one have?
3.
2. How many edges does this one have? 2. How many edges does this one have? 4. It has 4 going into that dot. How many here? 2, 2, 2. So there is none of them with an odd number. All of them are even numbers, so we could use Euler's for this one. This is definition of Euler's. So this one will count as A, diagrams that can be drawn without lifting your pencil from the paper. Okay, so A works for this one. But what about B? Does B also work for this one? Yes, so you would actually say, yes, this one does work here. And so number 5 does work here, and number 5 does work here. Let's look at another one. See number 2? Does that look a whole lot like what we did earlier today? Yeah, that's actually the same shape as what we had on our notes from yesterday. It is yesterday's notes. It's just squashed a little bit different. So it has the same spots. So let's see. So if we did this, and let's see, how do we end up starting this? I think we start here, right?
Oh, you're so smart.
There we go. Now, I started here, but I ended here, right? So, does this meet the requirements for a Euler's? No. Why? It does not end at the same point. But does this one meet the requirements for question A? Yes. This one doesn't have to end and start at the same point. So this one will be for A, but not for B. And go through and list it. So I started 1, 2, 3, 4, 5, 6, 7, and 8. Now, just make sure you're going through and numbering these. If you notice how I traced this out and I numbered each one of it, because that's what it says you're supposed to do. Anyone questions? All right, everyone should be able to get this done before the end of class. So, good job, good luck. Don't forget, like, share, subscribe, hit that notification button, and follow me on Instagram. Use the promo code PACHORULES, and you get 10% off your next cup of coffee.
Does anyone know